Hi there, I'm your Moondream Vision Assistant. I can see your camera feed and detect objects with green bounding boxes. What would you like me to help you find or monitor today?
Can you tell me what you see in my camera feed?
I see a person in the center, holding a phone on the left and bananas on the right. There's also a chair to the left.
Okay, tell about what is in front of the person.
In front of the person, I see a microphone.
Let's look at how to design and implement a custom modular AI pipeline for vision and voice agents in Python. We'll use vision agents along with 6 other AI platforms. The newly released reasoning model from Moonshot AI, that is Kimi K2 Thinking. We will access the reasoning model via Open Router. We will use ElevenLabs for text-to-speech and Deepgram for speech-to-text. Moondream for real-time object detection in videos, and the open source framework called Smart 10 for 10 detection in the voice AI application. Vision Agents is free and open source AI framework for building voice and video applications in Python. To build vision and voice AI applications in Python using Vision Agents, you can use 2 main architectures. The first one is the real-time architecture. For this, you can use OpenAI Real-Time API, Gemini Live API, or Amazon Nova Sonic. So in this tutorial, we will focus on the modular voice pipeline. For this, you can bring your own LLM, 10 detection model, speech-to-text model, text-to-speech model, noise cancellation AI technologies, and more. To build the custom modular voice pipeline in Python, we will use the newly released thinking model from Moonshot. This is a reasoning model that has an excellent support for tool calling. We can use it to call about 200 to 300 external tools to help the voice and vision agent to perform its operations. To access the Kimi K2 Thinking model, you can use the Moonshot API or use Open Router. In this video, we will access the model via Open Router, which integrates seamlessly with vision agents. ElevenLabs will provide a text-to-speech. We will use Deepgram for speech-to-text. Since we are building a voice agent that has sight and the ability to detect objects in the user's camera feed in real time, we want to use Moondream for the real-time object detection. For 10 detection, this refers to the agent's ability to determine when a user has started speaking and finished talking. We will use the open source project called Smart 10. So the project requires API keys from different AI providers. To run the sample demo successfully, you will need stream API key and secret, as well as this base URL. You will need API keys from Open Router, Deepgram, ElevenLabs, and Moondream. So once you initialize a new Python project using UV, you can store them in a .m file or on your machine shell profile. On the Mac, you can store them in your operating system .zshrc file or zipro file. These 2 files are hidden on the Mac, so to reveal them, you should press Command-Shift and H, followed by Command-Shift and period. Let's initialize a new Python project using UV and set up the working environment and configure the API keys in a .m file. I have opened an empty directory in Cursor, so let's bring the integrated terminal and get started. With an empty directory in Cursor, I will initialize a new Python project using UV with the command uv init. We now have these generated files. So in the project's root directory, let's add 2 files, a .m file to store the API keys. I have all the API keys I need for this project in my clipboard, so I'll paste them here. And also add a markdown file to give detailed instructions to the agent. I will then paste this content for the agent instructions. We have a Vision AI assistant that has the capabilities of identifying objects in videos in real time. We will reference this markdown file when configuring the agent in main.py. So I will remove the content in main.py and install Vision Agents. Since we have already initialized a new Python project with UV, we can install Vision Agents with this command, uv add Vision Agents, and press the return key. Running the command uv add Vision Agents installs the core Vision Agents SDK. So we have this version of the SDK. Since the command installs only the core Vision Agents SDK, we need to install plugins separately. So I'll clear the terminal and run this command. To install the Vision Agent plugins, Getstream, ElevenLabs, and Deepgram. Getstream provides the audio and video transport, allowing the agent to establish a video call via WebRTC. ElevenLabs is the text-to-speech component. We use Deepgram as the speech-to-text component, so I'll press the return key to install them. For the remaining plugins, we need to use uv pip install. Running this command, we will install the Moondream plugin, the Open Router plugin for Vision Agents, and Smart 10. We will use Moondream for real-time object detection, Open Router to access the Kimi K2 Thinking model, and Smart 10 for 10 detection. Again, I'll press the return key to install them all. In our main.py, I will add the following imports and configure login with call tracking and timestamp formatting. So we import the Vision Agents framework components, as well as the AI service plugins we just installed. Next, I will add a main async function to configure the voice agent. In the main async function, we will create a Moondream cloud detection processor object for real-time object detection. So over here, we initialize it with example objects to detect. Next, we can create the agent and configure it with a set of parameters. So creating an instance of the SDK's agent class, we add all the following parameters. Getstream Edge for low latency edge network. You can also integrate a custom implementation using WebRTC or WebSockets. Next, we give the agent identity and also read instructions from the markdown file we added previously. Then we add the Moondream processor for object detection. That is the processor we added here. And also specify the model we want to use. So we are accessing the Kimi K2 Thinking model via Open Router. The next is the text-to-speech component with ElevenLabs and Deepgram for speech-to-text. The last parameter in the agent's definition is the 10 detection. Over here, we are using the open source project Smart 10. Next, I will add the following code snippets to log startup message and initialize the agent. Then we create the agent user profile in the system. We use the unique ID to create a new video call. Then we add a web-based video calling UI to interact with the voice agent. After creating a new video call, we also need to join it. Then we add the following code snippets to greet the user once we run the Python script, and also keep the agent running until a user ends the video call. Finally, we will run the async agent when the script is executed. So this is how to build a voice agent using Vision Agents and a modular voice pipeline architecture. Using this flexible pipeline architecture, we can replace the components of the agent at any point in time. For example, we can easily swap the Moondream processor with Ultralytics or RoboFlow. We can change the Kimi K2 Thinking model with any supported model from Open Router, or use OpenAI, Anthropic, or Gemini implementation. You can easily swap the text-to-speech component, like replacing ElevenLabs with Cartesia. For speech recognition, we can replace Deepgram with Speechmatics, and also use a different 10 detection technology rather than Smart 10. I will bring the terminal with control and backtick and run the Python script with uvrun main.py.
Hi there, I'm your Kimi K2 Thinking Vision Assistant. I can see your camera feed and I can detect objects with green bounding boxes. What would you like me to help you find or monitor today?
Can you tell me what you see in my camera feed?
I can see a person in the center holding a water bottle in their left hand and a cup in their right hand. There's also a chair to the left and a book and table to the right.
That is everything I have for you in this video. We built a modular AI pipeline for vision and voice AI using the open source framework called Vision Agents. We implemented different custom AI technologies. Since the architecture is modular, you can replace any of the components of the AI technologies with your custom implementation. You can get started with Vision Agents by reading the docs. You can also check out the GitHub repo for advanced examples and use cases, or join the Discord community for discussions about Vision Agents and how to implement the open source framework with your AI apps.